Hello everyone, we are going to look at vectors. So I'm just going to answer questions from previous question papers. I'm just going to go right to it and waste no time. So the first question that we have here, I don't know if you can see clearly there, but it reads vector OC and OD are shown in the figure below. Determine OD minus OC using algebra. So basically you have this sketch here and then you have to determine OD minus OC. So what you do, you will write OD minus OC. But remember, these are vectors, so you must indicate with the line at the top. These are vectors. Okay, so now after writing OD minus OC, which is the question, you're going to check if ever the direction which is given on the diagram here is actually on the direction of the vector which is on the question. I don't know if it makes sense. When I'm trying to say OD, does the arrow indicated on the graph shows it starts from O and then it ends on D? So if that is the case, you are going to write OD as it is here. So we'll say now we have OD because we can see on the diagram it goes in the direction OD. Okay. And then now we're also going to check what? OC. OC is also going in the direction of what? Of OC. So we're just going to write the equation. We repeat the same thing. Minus OC. Okay. So now when we are here, we have to write everything. Let's say, for example, we have to get rid of this negative sign, write it as a positive. So what we're going to do for us to write this negative sign as a positive sign, we need to change the direction of OC. So we're going to drop OD the same way as it is, which is OD. Then it's minus. So remember now, when you swap the direction, you start with, you're going to say minus CO. So remember, CO is equal in magnitude with OC, but they are opposite in direction. That is why OC is equal to negative CO. Okay. So now you have this. You're going to write what? You're going to just simplify to say now you have OD plus CO. Okay. So now your question or your expression in algebra, it has addition. So now you know if ever you are adding your vector. Remember, when you add your vectors, you add them using head to tail. Let's say, for example, when you start here, your vector will move this direction and then it ends here. Then your other vector will start from where this one finished and then it ends wherever it is. Now your resultant, the resultant of these two vectors, it must start from where the first vector started and then it must end at where the last vector is ending. So this is how you determined the sum of vectors. Let's say this vector was A and this vector was B. So the resultant will be A plus B. So every time you have to start like this, use head to tail method, and then the resultant is where it started and where it finishes. So now here we're gonna write our diagram here to say now we want to start at OD, and then we want to finish at CO. Okay, let's say for example we'll start at CO and then end at OD. So it works better if we are doing it, we are starting here. We start at CO and then we end at OD. I don't know if you can identify that, but you will have to play around with it. So now that means here on our equation, we can write it this way to say now we have CO plus OD. So now remember CO, it will have to change the direction here. Remember it was OC and then we made it to be what? To be CO. That means this vector of ours, it has a direction that is going this way. So basically we're going to have what? CO plus OD will be equal to the resultant, which is a CD, from where the vector is starting up until everything is ending. So the answer here, it will be what? It will be D. Okay, so let's move to the next question. So the next question says that determine the unit vector. I don't know if you can see clearly, but it says determine the unit vector in the direction PQ, where P, it has this coordinate and where Q has this coordinate. So basically on this question, they just give you to say they want what? To determine the unit vector in the direction QP, but they just give you the coordinates P and Q. So that means now you have two vectors. Let's say is this vector and this vector. But these two vectors, they must have an origin where they both start. Let's say, for example, you can say this origin is what? Is O. This vector is moving this way, and this one is moving this way. And then we can say this one is P, and this one is Q. So every time the vectors will always have a point whereby they meet, they intersect, all of them. So we can just name it O here. So basically the coordinates of P here, they actually represent OP. And the coordinates of Q here, they actually represent OQ. So even if they give you a question like this, you have to be able to represent it here as a graph like this. Okay, let me just erase this graph here and put it aside so that I can work on a bigger space. So here is O, P, and Q. So they're actually moving this way and this way. Okay, so now the question says you must determine what? You must determine the unit vector of QP. So QP is here. This is what you are looking for. QP. QP. So remember now our QP will be what? Will be QO plus OP. So basically vector QP. Okay, let me just demonstrate that. So remember QP will be our resultant. So we must have, if we want to add vectors, we must start here and move to O, and then move from O, move to P where it finishes. And then the resultant, it will start where everything started and where it ended. So now our resultant QP, it will be equals to, so it starts here at Q, it's going to be QO is equals to QO plus OP plus OP. So again, let me remind you, every time when you are looking for a resultant, your vectors must start from here, it moves like this, and then the other vector will start where your vector is finishing. Let's say it moves like this, and then now when you construct the resultant, you will start from the where everything started and then where everything ends, like this. So this will be the resultant, this will be vector 1, and this will be vector 2. So that means the resultant will be vector 1 plus vector 2. I hope it makes sense. So basically this thing here is the very same thing here. Even if the direction is moving this way, we are just demonstrating to say the vector Q, the resultant QP will actually be the sum of QO plus OP, which is what we have represented here on the equation. So now that we have the equation of QP, now we can determine the direction. Now we can work with directions now. To say now we have QO, but QO, in this case we have the value of Q, remember it represents OQ. So now OQ is the same as QO in magnitude, but it is opposite in direction. So we'll be right to write what? QO as negative what? We can write it as negative OQ. Okay. So remember, we are saying QO, it moves from here, it starts from here, it ends here. But the actual vector, which is OQ, is actually starting here and then it ends here. So remember, the vectors, they are equal in magnitude, but now they are moving in opposite directions. So we're going to say QO is the same as OQ, but in different in direction. So this is equal to this, but different in direction. Okay. So now OP is actually in the correct direction because QO will move here and then it will end here and then OP will end there. So OP will just remain as OP. So it will remain OP. Okay. And then now when we have the equation like this, you can now add your vectors. Remember I said to you, this P is actually representing OP, and then so we're just going to substitute everything. So in place of OQ, we have what? We have 0i plus what? Plus 1j minus 1k. Okay? And then for OP, we have plus, let's say it's negative 2i plus 2j and then plus 0k. Okay, so now when we simplify everything, we're just going to remove the bracket by this negative. 0 will be 0, and then this one it will be negative j plus k. And then here we'll be having what? Negative 2i plus 2j. So at the end, everything will simplify. Negative 1 plus 2 is going to be what? It's going to be positive j. But we have to start with I. Remember, we have to start with I first. So we're going to start with negative 2i. Then we go to j's, and then it's going to be what? It's going to be plus j. And then for k is only 1k, so it's going to be plus k. So basically, this is what? This is the vector PQ. So now when you have the vector PQ, you have to do what? To find the unit vector of PQ. Okay, let me just erase at the top here. You can simply go back if you want to what I've wrote at the top there. I don't have enough space, so I just have to erase and calculate the unit vector. So remember the unit vector of QP, it will be equals to what? It will be equals to QP, it will be equals to vector QP divided by the magnitude of vector QP. Okay, so you are now at the top, we have the vector QP, which is how much? Which is negative 2i plus j plus k. Then at the bottom, we are looking for what? For magnitude of vector QP. So basically, we're gonna have 2 squared plus 1 squared plus 1k. 1 squared, I mean. Okay. So you can actually represent the unit vector this way to say unit vector is equals to 1 over, let's say it's going to, inside the square root is going to be 2 squared is 2, and then it's going to be 6. So it's going to be square root of 6 multiplied by the vector at the top, which is negative 2i plus j plus k. Okay, so that is how you answer this question. Okay, let's now look at this question. So in this question, we actually have what? They say in a triangle ABC. Okay, triangle ABC is shown below, where AB is A plus B and AC is 2A plus 3B. So basically, they say you must express the following in terms of A and B. So let's say, for example, we are looking for AB. So AB will be equals to, let's check our vector here to say we are looking for AB. So remember, this vector is actually BA, but we are looking for AB. So basically, AB is equals to negative BA. So AB will be equal to what? To negative BA. But now what is BA? BA is what? Is A plus B. So now the vector AB will be minus A minus B. So when you go to number B, we're looking for AC. So we're going to do the same. We look at AC. AC opposite direction. That means AC is equals to what? AC is equals to negative CA. So we're going to say we have what? Negative CA. But CA we know is 2A plus 3. So the final answer will be negative 2A, negative 3B. Okay, let me just erase for space. Then now we have to find what? BC, AC. So if we can look here, BC will be what? Will be the resultant of, let's say it's BC. BC, remember the direction is important. It's going to go this way. So that means BC will be the resultant of what? Of BA plus AC. So BC is equals to BA plus AC. So BC is equals to BA plus AC. Okay, so basically here on the diagram we have the value of what? Of BA, but here at the diagram at the bottom we have the value of CA, and then here on the expression we have AC. But we know now AC is equals to negative CA. So we can write it this way to say we have BA minus CA, and then we substitute everything. Now we know the value of BA is what? Is A plus B minus the value of what? Of CA, which is 2A plus 3B. Now when you simplify everything, negative 2A will minus with A, and then we have negative A. Then also negative 3B will add with B actually, and then we have what? We'll have negative 2B. And then this will be the final answer. So let's erase and look at the last one. So on the last one we have CB. we're looking for vector CB. So vector CB is actually moving in this way. Let me erase this one here so that you can see what I'm talking about. So vector CB is moving this way. So remember, if the vector is moving this way, that means we have to start at C to say CA plus AB is equal to the vector CB. So now we're going to say, okay, equals to what? CB is equals to CA plus AB. Then now we check at the direction to say, okay, we have CA, that's true. And then here, do we have AB? No, we have BA. So that means we have to write AB as BA. So now it's going to be CA minus BA. And then we substitute the values. The value of CA is going to be 2A plus 3B minus the value of BA, which is going to be A plus B. And then now when you say 2A minus A, you're going to have A. Then now you're going to say 3B minus B, you're going to have 2B. And that will be the final answer. Okay, so now let's look at this question. This question, it says now, find a vector. No. So this one, it says find a scalar product. So basically, there's a difference between a scalar product and a vector product. So when you see a dot, that represents what? It represents a scalar product. But when you see a multiplication, this represents a vector product. So we have to find a scalar product between these two vectors and a vector product between these two vectors. Okay, so when we find the scalar product, we say, okay, a vector u multiplied by vector v is going to be equals to 3i, which is vector what? Or let me just write it in a good way. So basically u is actually equals to square root of 5i plus 2j minus 4k. And then now you're going to say multiply by vector of v, which is 3i minus 2j plus 3k. Okay, so when we are looking for a scalar product, we're only going to multiply what? The same terms. Let's say if wherever we have I and I, we only multiply its coefficient and we get rid of the I. So you're going to say square root of 5 multiplied by 3, then we get the answer and then we don't put I. So remember, this scalar product at the end, it will only have a magnitude, not direction. So you're going to say square root of 5 multiplied by 3, which is going to be 3 square root 5. Then you also go to the second one, which is j and j. So you say 2 multiplied by negative 2, that will be negative 4. Then you go to k and k. So for k and k is negative 4 multiplied by 3, which is going to be negative 12. So when you put everything into your calculator, it will give you the final answer. I'm sorry that I don't have a calculator with me, but you can work it out and get the final answer. Okay, that is how you get a scalar product. So let's say now we want to find what? A vector product between the two same vectors. So remember, a vector product is denoted by a multiplication between the vectors. Let's say, for example, it will be like this. Okay, so when you find a vector product, you're going to use what we call a determinant. So on this determinant, you will have what you call I, j, and k. So remember, this is three-dimensional vector. So I, j, and k, it represents the direction of I and the direction of j and the direction of k. So it's three-dimensional vectors. So here you're gonna write on this row here, you're gonna write things that the coefficients of I, and then here coefficients of j, and then also here the coefficients of k. So now let's write the coefficients of I is gonna be square root of 5 and 3. And then the coefficients of j is gonna be 2. And the coefficients of k is gonna be -4 and what? And 3. Okay. So now after you have determined your determinant, so you're just gonna hide, let's say for example you want the values of I, you're gonna hide everything on I, and then you start to say for I will have, and then you will cross multiply to say now 2 multiplied by 3, 2 multiplied by 3 will give you 6, and then you put a negative sign here. And then this negative sign you will minus when you cross multiply from the other side. You say -2 multiplied by -4, which will give you a +8. So that is how you get value of I. And then for value of j, you put a negative sign. Every time when you want j, when you are looking for j, you will always have to put a negative sign. And then you do the very same thing. So that means now you will have to hide for j. And then when you hide for j, you're going to say what? You're going to cross multiply also. Square root of 5 multiplied by 3 is going to be what? 3 square root 5. Then also you're going to say what? You're going to say 3 multiplied by -4. Remember, you put a negative first. And then it's going to be what? A -12. Okay, and then lastly, you do the very same thing for k, but k, it has to be positive, same as I. It's only j that it has a coefficient of negative. Then you have to hide for k. So after hiding here, so you're going to say square root of 5 multiplied by -2. It's going to be what? -2 square root 5. And then now you're going to do the same, minus what? 3 multiplied by 2, which is going to be 6. Okay. Then now after using the determinant, you have everything that you want. Let me just erase here. Okay. So that means now your scalar product, remember your scalar product did not have a direction. It had an answer with a magnitude only. But now when you're looking for a vector product, it must also have a direction. So your answer will be what? When you add the things for A is going to be what? 6 minus 8, which is going to be -2i. And then for j here, you get the answer of everything here, then you multiply it by -j. So it's going to be what? It's going to be negative answer or a positive answer, doesn't matter, but you just put that into your calculator and you multiply with negative, and then it's going to be the answer j. Then the same thing for k here, so it's going to be plus the answer k. I'm sorry for that, I'm just demonstrating, I don't have the calculator. Okay, so that is how you find a scalar product and a vector product. Okay. And now on the next question, they say now find the angle between vector v and vector u. Okay. Like in question 2. So it doesn't matter, we can just create our own vector here. Let's say for vector v, we have 2i plus j minus 3k. And then for vector For vector u, we have, let's say 4i plus 2j and then plus 6k. Okay. So now they say we must do what? We must find the angle between vector v and vector u. So every time when they say you must find the angle between two vectors, know that you're going to use a scalar product equation. So a scalar product equation, it says now, you're going to say v, a scalar product of v and u is equals to the magnitude of v multiplied by the magnitude of u cos of theta. A theta will be the angle between the vectors. So when you simplify your equation, you divide both sides by vector u, let's say multiply by the magnitude of vector v multiply by the magnitude of vector u. So this will cancel out, and we know now we're going to be left with cos of theta being equals to the product of u and magnitude of v and magnitude of u. Okay. So this problem will be just straightforward because it was a continuation problem, but now we have to find the value of uv because we don't have it now. So for us to find the value of uv, we use a scalar product because it's a scalar product. So the cos of theta is going to be a scalar product of 2i plus j minus 3k and 4i plus 2j plus 6k, all divided by what? By the magnitude of v, which is going to be 2 squared plus 1 squared plus 3 squared, multiplied by the magnitude of u, which is going to be 4 squared plus 2 squared plus 6 squared. So now when you simplify your scalar at the top, you remember you just multiply the ones with I and then the ones with j, and then it will not have a direction because it's a scalar product. The scalar only has a magnitude. So it's going to be 2 multiplied by 4, which will be 8, and then it's going to be 1 multiplied by 2, which is going to be 2, and it's going to be negative 3 multiplied by 6, which is going to be negative 18, all divided by, then here inside the square root is going to be 9 here, and then 9 plus 1, and then it's going to be 14, so it's going to be square root of 14, and then here at the bottom 6 squared is going to be what? It's going to be 36, and then here we're going to have 4, that means it's going to be 40, then 40 plus 16, that means it's going to be 56. Okay, so when you use the calculator, you will get the right answer. Let's say example, the answer was is equals to 0.5. I don't know the exact answer. I'm just making an example. So for you to find the angle now, you will just say theta is equals to second function cos, and then you get the answer. No, this is not the answer. Let me just write answer here. And you just say you put answer, and then you will get the angle between vectors. Okay, thank you very much. The lesson ends there.